Yeah. So we're recording the class now. So I want to talk about class, and whenever you hear about class, what should come to your mind is a design. So a class is a design. Although in software development, it's mostly known as a blueprint. So when you hear class, what should come to your mind is an architecture who wants to build a house. You need to first of all make a design of the house. And you should know that the design is not the building. It is just a design. If maybe an engineer wants to build a car, the first thing he has to do is to design, to have maybe the prototype of the car that he wants to build. When he brings the design or the blueprint or the prototype, it won't run, but it will tell us that, okay, this car has the ability, the car want to make should be able to run. It should have a color. It should probably have a name. It should have a model. So if you say that this car should have a color, this color is an attribute of the car, should be what? Color. If you say, okay, it should have maybe number of wheels. Maybe I want a car that will have 6 wheels. So that is also what? An attribute of this car, the number of what? Wheels. That does not mean that you already have a car that has wheels. No. But that is in the design, the car should have some attributes, and it should have some functions, some things it ought to do, or it has to perform. One of the functions could be drive. It's okay. There should be a functionality. This car should be able to drive. We should be able to tell this car drive. We should be able to tell the car to apply brake, to put a brake, and the car will stop. So these are what? The functions or the methods of this class. So when you hear about class, understand it to be a design, a prototype, a blueprint. Then, and a class holds variables. The normal variables you know in Python, that you can say x is equals to 5. That x is a variable. The same thing in class, but in class, the variables, we call it attributes. And the function we've been talking about, a function that will add 2 numbers. In class, we call functions methods. So a class holds the variables and the functions to create the real thing. A class is just like a way of a design that shows the variables and the functions in order to do something. So that's just what class does. But now, after making this design of a class, when you now build the car, maybe you now say, okay, I have this class now, I want to build a car. You build a car based on that class. Once you've built a particular car, when you build the car now, now has a color, a particular color. Maybe I have a car now, the car is Toyota. The car has 4 wheels. The car is blue. The car can run. That is now an object. Now, so if someone asks you, go and get a ball for me. A ball is an object. Go and get the ball. It is an object. So an object, you can handle it. You can feel it. Someone can ask you, what is the shape of this object? Object, say it is spherical. What is the color of this object? It is brown. So it is an object when it has been created, when it has been instantiated. When you are creating the objects, we call it you are instantiating the class. Instantiation is like bringing the class to reality, bringing the class to life. Before, it is lifeless. It is just a blueprint. It's just a prototype. It's just a design that tells us the features or the functions that what you want to create should have. But when you are creating this thing, we call it that you are instantiating the class, meaning that you are creating something from the class. And once you've created that thing, we call that thing you've created an object. Okay. So now I want to create a class. First thing, we'll create the design, that is the class, containing information about, it has information on each student's record. So I want to create a class, and that class, we'll call it the student's record. Then, after creating this class, we have to do what? We have to create an object from this class. Now, I want to ask a question, and you can unmute yourself and answer the question. Let's say I want to create a class student record. Can you tell me what are some of the features that the student record should have? What I mean now is that when maybe someone goes to the department and they bring your record from the department, they say, okay, this is Tony's record. What are some of the features or some of the attributes or whatever that you feel that should be contained in that record? Someone should just speak out, please.
The student name. What?
A student's record, what should be the attribute or what are the things that we can find in a student's record?
Yeah, I said the student's name, like name.
Okay, the name, okay.
Yeah.
Correct,
Okay.
yes.
Department,
yes.
Level.
Okay. Level, okay. Good. So these, okay, scores, yes. So these are the, what we call it, the attributes. What you just mentioned now, the student's name, the student's, maybe student's age, the student's score, or the student's grades. These are the attributes or the variables that we can find in the class. Okay. So now I'll show you something. We'll take this thing one after the other. So just don't be overwhelmed by what you just saw now. First, to create this class known as student's record, let's create it together. First, we say we want to create a class. The class is a reserved word in Python. It's something that you shouldn't just use anyhow. It is used for creating a class. So this class, we call it record. So that's the student's record. So see what I just type class record. Then I will put what? The column. I will hit enter. Now, we said that I wanted to have the student's name. Sorry. I wanted to have the student name. I wanted to have the student's age. And I also wanted to have the courses the student is taking. Okay. This, just forget about what you are seeing down. Just focus on what I'm typing now. So this is a class known as record. This class contains the student's name, student age, and the student courses. So these are the major things that we want this class to do for now. Now, there's what we call a constructor. This is how this thing is now. First, this is a class that contains this. Now, when I want to create a student, a particular student now, maybe I want to create a student known as Tony. I want a situation whereby as I'm creating this student, I will be able to add the name of the student, the age of the student, and the courses of the student. And to do that in class, there's what we call constructor. Constructor is a method on its own, but this is how we define the constructor. You type def, you type underscore 2 times. Underscore 1, 2, then init, then another underscore 2 times again. So this is the way to instance, this is the constructor. This will help us to pass an argument to this record so that when we want to call this record, we'll be able to pass in these values into this record. So def underscore this, then we open this bracket. The first item in this bracket should be self. I will explain to you later, but I'll just give you an overview of this self. This self is telling us that anything that we attach this self to, it will be peculiar to a particular student. It's something that is peculiar to the student. So self name, because we want to pass in the name at the point of creation, then age, then finally courses. Okay. So I also put my colon. So I'll use my tab key to push these things inside because they are meant to be for that def. Now, the next thing I'll do now is I'm just telling Python now self.name. That is, I want to create an attribute. Should be equals to this name here. I'm binding this name to a particular student. I also do the same thing for age. Self.age should be equal to age. Then finally, self.courses should be equal to courses. Now, I'll allow you to ask questions, but wait, let me create an object so that we'll see what this thing does. Then you can be able to ask your question. I'll create another cell. I can just say student 1. The first student is equal to, I'll call this record. Record. Then inside bracket, you see, there is name, age, and courses. This name here, this age, and this courses. Then let me call this name maybe Tony. Or let's do it a bit official. So this is first student. That's the name of the student. Then the student age, let's say 47 years. So the courses. Okay.
First, truly 47, sir.
Sorry? Come again.
Your age, sir, 47. Okay, sir. That's good, sir.
We are talking about Anthony Machuku. Okay.
I know,
and
sir.
there are many
just
Anthony
kidding.
Machukus in the world,
I was just
right?
kidding, sir.
Okay.
Thank you, sir.
All right. I grab. So now these courses, I want to do something. I want to add an entity list because when we're creating this thing, let's say that the students have not started registering any courses yet at the point of creation. So we don't need courses yet at the point of creation. So we just want to just create a student with the name and the age. So I think this is enough for that. So now after creating this record now, this is one record. So we can then print out the student words. We can just say student age dot age. Okay. So now, first is that we define the blueprint, which is a class. And this is what we did. We type this keyword class, then the name, any name we want to call it. And now we want to call our own record. So now to pass in the argument that will be passed into this class, like this record, we are passing in 2 arguments. Those arguments, you have to put it in a def, that's in a function, or you call it method. So this function now must be this. It has to be 2 underscores in it and 2 underscores. And the first item should be self. Then any other this thing that you want to pass into it, you then list them. So now we are now saying, okay, for this name, attach it to this name, to self.name. For age, attach it to self.age. Then for courses, we want to create an empty course. So you see here that we just did it here. Now from here, this this is a class, which is the blueprint. These are the attributes of this class. That is the variables contents in this class, the attributes. So here, this is the point when we are actually creating, we are instantiating the class. When you call the class and you pass in the attributes inside this class, you are instantiating the class. And when you instantiate a class, the result of it is an object. And this object now is the first student. So we can get the name of this first student. We can even get this is the age. We can get the name also. We can say student1.name, Anthony Nwachukwu. We can get the courses, student1.courses. Nothing here. Let me change this. Change presentation. Okay. All right. So student1.courses is giving us empty list because there's nothing contained in the courses. Now you may ask your questions. I know there are questions, so ask your questions now. And please, there are a lot of students in this class. It's just one or two persons that have been talking or asking questions. Others, could you please just ask questions? Of course, if you don't ask questions, that means you understand, and I could point at you to explain one or two things to me. And you should be able to explain it because you're not asking any question.
I have just two questions, sir. First, you said you're going to explain this self. This self,
okay.
Yeah, I don't know if you could explain it because I see it when you are defining the init, it was the first parameter inside the parentheses, and then you also used it to reference the attributes that you created, like .name, .age, and .courses. Please, could you explain more about this self? Is it a keyword? Can we change it or not? And the init, that's my second question, sir.
Okay, first that this self is a keyword. Requires that transition be enabled in the meeting. Okay, so this self is a keyword. As you can see, even the way Python gives it here, I mean, the color and everything, you see, it's called self at record. Now, you see this self, what this self does essentially is it binds these variables to a particular student. It's just telling us that when the user adds this Anthony and this, let it be attributed to this student that we are creating here. The reason is because, I mean, we can create more than one student from this particular record. We can create a second student. We can just call it student 2. Is equals to this record. So now let's use Prince. Prince Uchenna. So Prince, what age?
You can put 52, sir. Let's manage
52. Okay. All right, so 52. So this 52 now, then here we can, maybe the age, you can get the age of this student 2. So what this self does is that it binds each of these towards, like this self.name is creating a variable, but it's saying that this variable is peculiar to the self. When you say myself, means it's peculiar to me. It is not something general for everybody. It is just for me. Okay, myself, it is mine. This name is my name. This age is my age. These courses are my courses. So they are attached to me. So here they are, it binds each, like this name. It's saying also, okay, once we add this name, let it be what? Attached to this particular student we are creating. And when we call this Prince Uchenna, it is attached to this other second student we are creating from it. So that's what the self does. It binds these variables to the specific list. I think we have class variables and we have class variables and I think instance variables. So the instance variables is the particular object you create. You create a particular object. So this self will bind this variable to that particular object. So that's what the self does. So anytime you are creating a class, it is, I mean, there has to be self in this, in order to bind these things to it. Okay. So Uchenna, what's your second question?
Init.
Yeah, init is, as the name suggests, initialization. That's init is a short form of initialization. So what init does is that use it to initialize. And when I say initialize something, means the default name. If you are creating this record, what are the default values that you want to pass in? So that, because we can actually change some of these things. We can change this. So, but this default value, like for instance, we can just change the age. Can change the age of the student 1 to maybe 23. So after changing this age to 23, when you run this, remember that initially the age was 47. So when you go back here now, it says student 1.age. The age has changed to 23. So essentially what this thing does is the init is whenever you are creating this object, whenever you are creating the object, the initial values that you want to pass into it. So if you want to pass in the initial value, maybe only age, that means you don't need to put name here, just put in only age. Remember that these courses, even though I did not put courses inside here, but since there's self.courses, I'm initializing it to be what? Empty string. So anything you want to initialize, any default value you want your class to have at the point of creation of the method, you have to put it in the init function. This is a function, although functions inside a class is known as method. So this is a method. It's also called constructor. It's called constructor. Okay, so yeah. So people should ask questions.
Yeah, sorry. Please, what's the purpose of the define? I mean the def.
This def here.
Yes, please.
So we use def to create a function. In Python, def is for creating a function. Last class we had was on we talked about functions. So when you want to create a function, you have to use def. That's a keyword used to creating a function. So here we actually created a function here. And this function happens to be init function. But I told you that because this function is found inside a class, we'll call it a method. But if it is outside, if it is not in a class, if you want to write a function, we call it function. But once you bring a function inside a class, it is known as a method. So this def is a keyword for creating a function. David, did you understand?
Yeah. Thank you so much.
Okay. So do you still have questions? Festus, do you have a question?
Just wanted to be just a clarification.
Sorry?
Just a clarification. Can this self be replaced with any other word?
I can't hear you well.
Can the word self be replaced by any other word?
Self?
Yes, can we replace it?
Self is a keyword. It's a keyword here. Now see.
Okay.
You see the color is no longer the same. Even though from my knowledge, I think it should work because when I was creating class with things C++, it worked. I mean, I could change this thing to be anything in C++. But let's check. Yeah, you should still be able to work in Python also. I've not tried it before, but it works. You can call it anything, but the fact is that anything you put here as the first the first argument you put here, like if you want this thing to have only age, name and age, anything that you put first, Python will take it to be what? A self. Anything you put there, it will always take it to be a self. But there are conventions in programming languages. The convention is always to use self. Always to use self if you're writing a code, since you're not the only person that will read your code, so in the community, it's always self. And that's why you can even see here, it gives it a unique color because of that. But you can replace it, but I won't advise you to do that because you're not the only person to read your code.
Okay, thank you very much.
All right. More questions? Dunsin. Dunsin, Friday.
No question.
Please,
No question.
if we want to use a one-line code to impute, take for instance, student 1, the record, student 2, student 3, is it possible to do that? If yes, how?
Sorry, a one-line code.
Without saying student 1, one line, student 2, another line, student 10.
Of course, it should be possible, but even though it's one line, does not mean that. It doesn't mean that it's actually one line. What I mean is this. Maybe, the code will get a bit complex, which I'm trying to avoid. I could put all the names of the students in a list, put all their ages in another list. I can use a list comprehension here. And I can just say students. The thing will get a bit not too good. I can just say students is equals to record. I can just create a list here. Then I can say record. Let's say I have the names of students already. I can say record I, ages I. And then I can say forward I in range of what length of maybe the names. So you see that this will actually give me, let's say we have names to be equals to Anthony, maybe Prince. And I have ages to be equal to, that was 47 and 52. Now I can decide to print this. Yeah, this gives me, see, this gives me all this, but let's say, I don't really like this, but let's say we want to get the ages now. Maybe, yeah, since there is age here, these are the ages. Can start to get the names. The name. This will give me the name, but of course, this is, I don't, we need to first of all understand how to do this little one before we start talking about all this. We won't even talk about this in the class because to me, it's not really this thing. Important to talk about this for now in class, but in case that's you want to do things like this, it's possible to do things like this. So since I'll delete this. Okay. So the first thing is just to understand how this thing works. Now, let's go a little bit further. This is a class known as record that has attributes, the name, the age, and the courses. We want to give it some functions. We want this class to do more than just giving us the name of the students. Let's add course. You know, when a particular student registers, we'll have the information about the student, we'll have the record of these students, but the students' courses are still what? Empty. We should be able to add a course. Can say add course. Okay. We can add a course to this student, and maybe we can just use the course ID. The ID of the course. So, and mind you, every method should start with that self before whatever you want to add. I mean, this self should always be the number one thing in any method you are defining inside a class. So we can now say self dot courses. These courses, we want to add something to it. Once someone calls this method add course, you should be able to get this course, do what to it, dot append the ID to that course. So when the person appends the ID, the course has been added there. Yeah, so we just added something now to this class. We added a method or a function. So this function is to add a course. To add, because we have an attribute here, which at the point of creating this record or creating the object, it is said to be empty. So after creating this student's record, and this student goes to the class and decides to register for a course. So what the teacher will do is just to add a course for the student. And by adding a course to the student, it will get the original course of that student, which is for now empty. There's the original course, which is empty for now. It will append this course ID to it. So let's check that out.
Excuse me, sir. Where did you get the ID that you added?
The ID, I've not added yet. Is at the point of adding the course, that's when we add an ID. So for now, I just created a course. It accepts an argument, or it has a parameter ID. So it will expect the person to add the ID. Why calling this method? Let me show you how to use it. Probably you understand by then. So let's say, for instance, now this student one created here, the courses. If we print this, if we run this, so now the courses is empty. Now let's add a course to this student. We want to call this method. I'm copying this. Copy. So this student one, I want to paste it. Oh no, it's copied everything. Let me just type it dot add. Okay. Add courses. Now it's expecting what? An ID. Let me call that ID Maths 101. So now for student one, it has added Maths 101 to that student. So when you call this student one.courses again, when you call it here, let's see. You see what happens? Because this is add course, it accepts an ID. And once it gets that ID, it calls this self.courses and add what? The ID to that course, it appends it there. So what we just did here, we first of all created an object known as student one. So then we call this method to add a course, and we imputed the the course ID. Then after inputting it, we're now calling on student one, we're calling the courses again. Initially, before adding this course ID, when we called the courses, it gave us what? Empty. But now we have the course added to it. Then let's call it again. Let's add another course and call this thing again. We can add another course here. Let's call this one maybe GST 304. So for this student one also, we are adding another course, GST 304. So let's print the courses. You see now, Maths 101 has been added and GST 304 has also been added to this particular student. You can ask your questions. I know you have questions, just ask.
I have a question, please.
Yes.
Why won't you add everything together separated by a comma instead of copying them and pasting them in another new field?
Okay. Yeah, the reason why for this, I mean, you could actually do that if maybe the student is registering many courses at a time, but this one was just designed to add just one in case probably you went to a particular lecturer and say, please register me in this course. That lecturer teaches you just one course, so the lecturer can register you into what? Only one course. So the lecturer will then say add a course. Okay, what you are saying, we can actually create another method that can do that. You can say def add multi courses. So IDs. I'm adding S now. I mean, of course, you could call it anything you want, the ID or whatever. So I can now say self dot courses. What am I now? See, these IDs now will be a list. So since it will be a list, who can tell me what am I to do here? This will be courses self.courses dot what? Just speak. Just what do you think?
Extend.
An empty list.
Sorry?
Extend.
Extend, yes. So we're extending the list by what? The IDs. So now let's run this again. We'll run this. We created the student first. We call the courses, it is empty. We added one course. We call it again, it's just one course. We added the second course. We call it again, is this. Now let's try to add multiple courses at the same time. So still on student one, dot add what? Multi courses. So these are the courses now, we put it in a list. We can say biology 203, comma, sorry, comma, then we can also say maybe chemistry 405. Maybe let's add one more course. Then maybe, I don't know, engine. What's this? Okay.
Maybe physics.
Okay, physics, okay. Physics is IPH or PHY. Physics 101. So after that, then let's call the student again. Student one dot courses. Courses, let's run it now. Okay, record has no attribute. What? Okay, yeah, sorry. It's courses. So you see, the previous courses, Math 101 and GS 304 are there, and it has been extended with this one. So these ones has been added to it. Yes, but hold on. You know what happens here? When we run this first and it gave us an error at this point here. So it has already added this thing after the first line before this error occurred in second line. So when we run it again with this error corrected, so it's adding again this. So that's why this thing repeated twice. It's repeating twice in the list. So the more you run it, the more it keeps populating it with this. So maybe for clarity's sake, let's run these things. Yeah, so that's actually it. Then it extended the list by this. Yeah. So any more question?
Thank you.
All right. Thank you.
So,
What if we want to delete? Okay, first let's ask a question. Yeah.
does it mean that we can actually use
Sorry?
add? Does it mean that we can actually use add in place of extend?
You can use R.
Does it mean that we can actually use add in place of extend?
I don't understand.
Student 1 add
Mhm.
multi courses. Is it actually this add multi courses?
Add multi-courses.
Yeah, I'm asking if it can, if it's like if it's the same thing with extend.
Okay, you mean we can say student 1 dot courses dot extend. Is that what you mean?
No, like
Because now
student
remember
1
this
dot no student 1 dot extend.
now see this add multi-courses is actually
Oh.
doing extend.
Okay.
Okay.
Yeah,
Yeah. So that's actually what it's doing, to extend.
okay.
Yeah. Okay, so let's know that all these things we are doing, they actually what for student 1. We can still create another student, student 2. So this student, we can check his own courses. This student's courses is still what? Is still empty. While student 1 already has many courses assigned to him or that he has registered. I can still call the student 1. The courses are still the same thing. While student 2, his own courses are still empty. So we can also, the same thing we did for student 1, we can do it for student 2. Let's say for student 2, we decide to, let me create this here. This is student 2. So we want to add courses for student 2. So let's add different courses. Maybe, which course should we add for him now? I don't know. ARE 222. Maybe FST 455. So after that, then we can actually do this courses. So the student 2, this is his courses. While student 1 courses still remains what? Student 1 courses. So we see that anything we are doing here is only affecting the particular object or that particular student. That's the only person that the thing is affecting. It's not affecting any other student. So that's just the beauty of object-oriented programming. This is the OOP you always hear. If you hear about OOP, OOP means object-oriented programming. That's we create an object. So when we say student 1 is an object. It's an object of the class record. And we create that object of that class by instantiating the class. I mean, that's just the big deal about OOP. So I know it's a bit confusing, especially for those that are coming up. In fact, let me give you a disclaimer. Yeah. For those of you that probably, of course, it may be confusing, not just for you, me, it took me many years, of course, to understand object-oriented programming. I mean, it took me some time to really understand it. So if it is confusing to you, it does not mean that you're not intelligent. It does not mean that you can't do programming. It does not mean that you can't be able to do data science. No, it's not true. I mean, when I did my boot camp, I was the only one that knows object-oriented programming in my boot camp. And every other person graduated, built some wonderful things, some app that does some predictive stuff without knowing all these classes things. But there's one beauty of knowing this. It makes your work neat. It makes your work appealing. It makes your work attractive. It makes your work cool. It also makes the work very easy for you because it helps a lot. So if you know it, it will help you. But even if at the end you still struggle a bit and struggle a bit, yeah, I mean, still go back to it again. Even if you struggle, still go back to the time will come, you will get used to it. Yeah, and until you get used to it, just keep going back to it. But even if it takes you some time, never mind. You don't really need it to be a data scientist. You don't need it. But if you have it in your portfolio, it will be a plus for you because it will help you to write a very good code. Yeah, so that's why I decided to teach it, especially for those that will be able to grasp it. For those that are not able to grab it, there's no problem. It's not a big deal. It's not one of the requirements to be a data scientist. But it will be very cool if you know it. And since I have to teach it, I have to teach another part of it, which is called inheritance. So if you're able to understand, if you are grasping it, just follow on. So let me talk about inheritance. Inheritance actually is just what you know of. You know, when you talk about inheritance, there should be a father or a mother, or there should be a parent, and there should be a child. When you talk about inheritance, it has to do with parents and child. So that's just the thing here. It's still about class. So we have a class, which is the parent class. Then we'll have another class, which is the child class. Take, for instance, we all are human beings. But some human beings are teachers, while some others are students. So even though everybody is a human being, there are some things that a teacher, some attributes that a teacher has, that not every human being has it. So a teacher could have some attributes, for instance, the courses the teacher teaches. Why the student, who is also a human being, does not have the courses he or she teaches, but he or she may have courses that he or she attends. So there is a human being, and the human being there is the parents. Every human being should have a name. Every human being should have an age. Every human being should have the sex. So these are the properties of this parent class, human. I created a class, I call it the parent class. I call it human. So this human should have name, age, sex. And of course, every birthday, your age should be able to increase. So this function is just a function that will increase the age. So this is the parent class. I will tell you how this parent class relates to the child class. So I can just call a human being one. I just call, oh, this human being is, then the name of this human being is Faith. This is the age. He or she is a female. The person is a female. So I started to print the age, and I started to increase the age by, I just run this increase age. Then I print the new age. Discover that the first, run this first, then run this. So the first time I printed the age, it was 66, which it was created with. Then I run this age.increase age. This increase age will automatically take the previous age, take it here, add 1 to it, and I reassign it again to that previous age. So that's why after running this age, let me split these cells.
Excuse me, sir.
Yes.
Where did you get this human construction function that you are calling? Because I'm looking for it, I can't find it. Okay.
This one?
Okay, I've seen it here. Yeah, class.
All right. So this, then the first human being, the age of that person is 66. Then I come here and I want to increase the age. After increasing the age, Then I'm printing the age again. I've increased the age is 67. I printed it again. If I run this cell again, it will increase the age again, 68. If I run it again, it will increase it again. So each time I run this function, it takes the previous age, add 1 to it, and reassigns it to that age. So that's what happens here. So this is like a parent class, because I mean, this thing is just to show you that this thing is a class and can stand on its own. So this is a class now, which is the parent, a human being. But I can create another class from this class. Let's say I have another class which happens to be a student. So instead of me in this student now creating a name, age, sex in this student, I mean, I already have a class that has age, name, sex. So what if I just inherit from that class those ones that I need? If I can inherit this name, age, and sex from this class, then add the remaining items that are not contained in this human, which I need in my students. That would be nice. So that's why I now call this one, and this is another class known as a student. That's a child class. So this is how I construct this one now. This one is class, student. So I will now put a bracket. This is the parent class. The class is inheriting from. It's inheriting from this human, that's this class up here, this one. So it will inherit every attribute of this class. So now when I was calling it here, so in the init, of course, I want to pass in a name, I want to pass in age, I want to pass in the sex, the student ID, and the student level. I want to pass those arguments. So now this second line here, what this second line does is now, take note now, name, age, sex is already contained in human. So the only new thing here is student ID and student level. So I have to put those ones here. These are the student's ID and the student level. Self.student ID is equal to student ID. Self.student level is equal to student level. These are the only new ones. Now, for these other ones that are already contained in the human, the way I can pass this argument into the human is by using this is a reserve key, a reserve word in Python, super. This super, like this, dots the init, because I want to initialize the parents. And the parents takes name, age, and sex as arguments, as you can see in the init of this parent, this human, name, age, and sex. That's what the parent accepts as an argument. So name, age, and sex. This will automatically bind this name, age, and sex to this human. Then all these other ones can then be defined here. I'll show you how it works. Now, I can now create a student. This student, the name is BC. That's this name here. The age is 23. The sex, he or she is a female. The student ID, this is the student ID, and the student is in level 1. Level 1. So now I can call student.age. I can run this and you see what happens here. Even though age is not here, but for the fact that we are inheriting from the human, and the human has name, age, and sex, you see that function dot age, okay, I mean, yeah, dot age, we can actually get the attribute age using this, which is 23. And even though I did not define the function here, increase age, but since that function was what defined in the parent class, this new class automatically inherits that function also. So this new class, which is this new class, which is to increase the age. I mean, sorry, the method increase age, I can call it on this student 1, and it will automatically increase the age of this student 1. So essentially, this tells us that it saves us a whole lot of pains to use inheritance. Since the human contains some methods and want to use those methods, want to use those functions inside it. So instead of us writing them again in this student, we can just put that, the name of that class inside the bracket of this student, then use this thing to pass the argument into that parent class. Then we can go on to us to use the attributes and the methods of the parent class. The same thing we did here is this student inheriting from human. Teacher can also inherit from human because the teacher is also a human being. So the teacher here is also inheriting from human. But now, apart from this age, name, and sex, we have teacher ID and we have the subject that the teacher teaches. So we also do the same thing here. So here we can just say teacher 1 is teacher. We pass in this argument. That's the teacher ID here, the teacher the subject. Then we can also do the same thing as we did for the students. Yeah, I know you have questions, so you can ask your questions.
More than question.
Paul, you can
It's
ask.
like
Sorry, Prince. Prince, hold on. And Paul raised his hand first. After Paul, then you can ask. So Paul, you can ask your question.
This human and teacher, are they keywords, or we can use any word in place of human and teacher?
You can use any word. That's what we just name it. Teacher, just like the other, yeah, teacher, student, they are not keywords. The only keywords here is this class. This class is a keyword, of course, the def is keyword. So class is keyword, but the name, you can call it any name you want. We just call it teacher. That's the name we want to give to the class. Okay, Prince, you can ask your question. After that, Onyeti will ask.
Let her ask, because me, I'm thinking of how to ask you to start afresh and explain this whole thing. I was following you, but I got confused in the middle. Like this super function, I want you to explain what it does, because you used it with init again here. You explained that it's just like work as inheritance, but I don't really know how to use it, as you have explained it here. And then secondly, could you scroll up to the child class?
Yeah.
Yes.
Yeah.
And here again, students. I don't confuse for my question.
It's okay. It's okay. Okay. What I said is that the super init. First, we know that the student, this def init is to initialize, right? To pass in the initial argument of this student. Now, when we pass in this, when we get this initial argument, like when at this point here, when we are getting this initial argument for these students, when we are getting this BC 23F, BS 23 and 1, and this initial argument, it enters this init. What happens to it? We discover that the age, the name, the age, and the sex is found in the human. That is where we want to inherit it from you. We want to inherit the properties of this human. So we are passed, and this human now needs name, age, and sex. It is the same thing in the init of this human. This is the init of the human. That's the parent class, the name, the age, and the sex. So since we want to inherit these properties of this human, we need to pass in the arguments that this human accepts, which is the name, the age, and the sex. And the way we pass it in from the child, the class that is inheriting from it, it is using this. So this thing is the key, is a keyword or key whatever. It has to be, Python expects it to come like this, okay? So this is super dot double underscore, the normal init. It is just telling us that, okay, this human you are inheriting from, it needs this argument. It has an init, and the init of this, look at it, the init of the human needs name, age, and sex. So this super means the super class, which is this human that is passing through here. That's the super class, the parent class, the super class. So that's just what happens here.
Okay. So now the parameters you passed inside this student is inheriting from human. And now you
Yes.
define the function just after the class student human, you define the function init, then you put self as the unique parameter,
Yes.
then followed by name, age, sex. Now, these first three parameters, you don't need to declare them since the student is going to inherit it from human. So you now have to use super.init to bring those parameters to so that the student is going to inherit it, right? Then student
Yes. So,
ID and student level, you now have to separately declare new variables for those ones, which is student
for those
self.student ID.
Yeah. Exactly.
At the end,
Exactly.
why did you
Declaring the new one
annotate
for
it
those.
to none, sir?
Sorry?
Why did you annotate it to none at the end?
Oh, I mean, normally, I mean, this is like telling us the type of the return function. I mean, you can remove this. If it confuses you, you can remove it.
No, it's not
Okay.
confusing
It's
me.
just like, okay.
It's not
Okay,
confusing me. The annotation, I just wanted
Now,
to know if you use none as the annotation,
yes.
is it as good as
Yes.
not even putting it at all since it's still none?
Yeah, but you know one thing, even when I was teaching you, functions, I wanted to put this. In fact, I put it in something I call it advanced whatsoever.
Yes,
Yeah.
advanced function.
It's just a way of telling the user that this function returns nothing. Because if you check, this is a function, but it's not returning anything. You didn't see anything return here, right? Normally, when you write the function, you're supposed to say return.
Just performing a task.
Assuming you want it to if you wanted it to return maybe a number. So this thing should be what? Int.
Integer, yes.
Integer. Yeah, so, but it's not returning anything. That's why you just say return none. Yeah, that's just this. I mean, it's not necessarily, I mean, you don't only put it here. In fact, for any function you create, it's good to put the return type. And not only the return type, even the arguments. Like, if I was to write my own function now, for instance, this name here, I'll put something like this to tell the user that this name accepts an argument string. This is what I'll put here. For this age, I'll put this thing here that I want it to, what is accepting is what? Integer. So that's just this is, I mean, is the proper way of doing things, so that when the user wants to call it, to tell the user, oh, this thing, this name here should be a string, this age here should be an integer, and this function is returning what? Nothing, or returning integer or whatever. So I'll take it back to how it was. So just take it as it's a convention, but you can remove it. Okay, two persons were raising their hands.
Yeah, I wanted to ask a non-question, but someone already asked it, so I'm cool.
Okay. 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 So,
Yes, I have a question, please.
okay.
A question and a proposition. Like the place you said, increase student age. What if you mistakenly increase age by running it many times? How will you bring it back to the normal age of the one that has been increased by 1? The second, is it possible for you to share this your scripts with us?
The script's already on EduFlow. I think I said it at the beginning of the class. EduFlow,
I mean,
the
the
materials
soft
already.
one, the soft one like this, the one you already
Yes.
solved like this. Yes.
It is solved already. I mean, it's on EduFlow. That's this note I'm using, this notebook, it's already on EduFlow.
Okay.
Yes, it's already on EduFlow. I did everything, then put it on EduFlow. So you are saying, in case if maybe you did the add, right? The add age. Okay, let me go back here. I think it's here. This age, and you want to send it back to the former one.
Yes.
I mean, the question now is that if you run it 3 times, so is it that you want to send it back to the past one,
Yes, like if you run it like 4 times, and maybe you already have a lot of scripts and you don't know how to take I don't know if you can return it back to the initial, the first one that has been increased by +1, and ignore the multiple ones you have already increased.
I mean, it depends. It depends on you. You can add that as a feature in your function that can do that for you. But the question now is that, I mean, since it's just doing by one, maybe if you want to check how many times you've run it, I think that could be a possible thing that probably you want to check how many times you run it. And if that's the case, then you can just say here self dot count number of what, or you can just say number of runs. Number of runs. Okay. I mean, it's just something you can just play around with. That means initially the number of runs is what? Is 0. So each time you run this, you should then call that self dot number of runs. You should call it. I mean, it's essentially almost the same thing this A stuff is doing. It will just call it and +1. So let's say you run this, then you increase the age, you increase age again, you increase age again, you increase age again, you increase age again. And you don't know how many times you've increased the age, and you want to find out how many times you've increased the age. You can just say human 1, right? Dot number of runs. So you've increased age 5 times. I mean, I don't know if this answers your question. It may not really be the.
Yes, it answers everything. Thank you. But is there no possible way you can set it to only run +1 without not running it multiple times? Like you run it to so particular +1 age and then give it a command to stop.
To stop. I mean, these are it's from, okay. You can just say something like if what this number of runs, okay, is greater than 0. Okay, let's say if this thing is equal to 0, it should do this. Okay, and whenever it does this, it should also do this one. So by so doing, yeah. Once you do this, you've achieved what you are just saying. Like now, if we go here and you run the increased age, you run it again. Sorry, here's increased age. Okay. Here, if you run it again, you run it again, you run it again, you run it again. No matter how many times you run it, it remains what?
Perfect.
67.
Thank you.
Okay.
It's perfect. Yeah.
So all these ones are you just use your intuition and try to manipulate around them. Yeah. So
I have a question.
Okay, ask.
Still on the function increase age. So why didn't you put like self comma age in the brackets? Why is it just self?
Now, why didn't I put what?
Self comma age. Like why didn't you include age inside the brackets?
I mean, like here, I'm just in here. I'm just assuming that you are increasing the age by 1. But if you want to increase the age by anything, maybe by age, if you say, then that means that you're saying this plus what? Age, right?
Oh, okay.
And when you do this, now for you to increase this now will accept what? A parameter. You are saying it's accepting a parameter A. So maybe you want to increase it by 5. So it's 66 plus 5 is what? 71. And of course, you can run it as many times. It won't do anything because of this condition we gave here, because after the first time, it increases this number of runs, and this number of runs is no longer 0. So no matter how many times you run it, it will still remain the value after the increase. Does that answer your question?
Okay, yeah,
Okay,
thank you.
all right. Any more question? Okay. I think we've exhausted all the questions, and of course,
Uh,
so
I have one.
Thank Jesus.
okay, you can ask.
So it does mean that it is possible to use if statement without an else.
It's possible to use what?
Is it that from your statement, that means it is possible to use an if statement without an else?
Yes, I mean, even when I thought the if, the first thing I thought about is if without else first. You can use if without else. That's the condition that runs. If that condition is met, it will run. Then if it is not met, you don't expect it to do anything.
Okay.
So it's possible. Yeah. So any more questions? Okay. So guys, the original notebook, as the notebook as it was when this class started, is on the Discord. Then these ones that we did, I mean, if you want a more organized notebook, that's the way it was before the class started. It's already on the Discord. Then if you also need this one that we did some manipulations, and I can also send it also to the Discord also. I mean, sorry, not Discord, to EduFlow. I think I'll put there in EduFlow, I will put that's the notebook after the class. That's after class notebook. I'll push these ones there also. So just take your time, try to understand it. I mean, in interviews, as a data, if you are doing interview for data science, especially, or even programming, whatsoever, once they ask you, do you know class? You say yes. It gets a bit interesting because most data scientists don't know how to use class, and yeah. So anytime they write a code, after writing their code will be shipped to the software engineering guys. The software engineering guys, they have to refactor the codes they've written in order to make it fit for production. But if you have this skill, your code doesn't need to go through much process before it will get to production. Yeah. And of course, if you want to be a data engineer, then you need to know class. Very important. All right, so I think we've already taken much time from today's class. I know that the concept that was taught is a bit advanced, yes. And don't be scared. Next week won't be this advanced. Don't think that it's just.
We have
Okay.
faith. We have faith. We will not be scared. Just that next week you have to start afresh again, sir.
So next week, don't think that the curve is increasing. No, next week we'll do something interesting. We'll start playing. At least you've been doing SQL. So next week we'll start thinking of how can we do some of these things that SQL can do. How can we do it from Python? That's when we use pandas. When we can bring, we'll start playing around with CSV file or Excel. You bring a file, maybe all those some of those files you use in your SQL, those data, we can bring them and load them in pandas, and we'll start manipulating it. We can even start summing some things, all those aggregation. We can do those things with directly from Python without using SQL queries. So I think that's what we'll talk about in the next class. We'll talk about pandas and NumPy. Yeah, and please, for the assignment for this class, is in groups, and I've grouped you. So if you go to EduFlow, you see the group in there. Contact your group members. Contact them on Discord. Of course, go to Discord, the general channel. You can type in this thing. You'll be able to see your group members. Then contact them, and you guys just work on this stuff. Yeah, it's just very simple. What I
Hello?
just want you to do is that, and what I want you to do is that already in this class, we've talked about human class, we've talked about students and all this. I just want you to just think of anything in life, any other thing that is not human. Create a class from that thing and create the subclass, that's the parent class and the child class from it. So that's just essentially what I want you to do. When you go to EduFlow, you'll see more of it. Yeah. Okay, someone is asking, I'm unable to open the instructor's reviews on my assignment. How do I access it? This is locked and if it is locked and you're unable to open it, it means probably you've not submitted your assignment. Yeah, because if you submit your assignments, the instructor's review should be open. And if you submitted, okay, and we can look at it together. Abimbola.
So can we start going now? Like,
Yes, please.
Okay,
You are free to
yes.
go. I'll stop sharing and maybe I'll stop recording too.
all
For
right,
those
thank
that
you.
have problem and want my attention, I will